In this video, I am in position to give you one insightful concept about Python function and related topics. In particular, we will see what Python functions are, how to define Python functions, and what are arguments and parameters, which are closely related with the concept of function writing, and how to invoke functions. And we shall try to distinguish built-in function from the third-party functions. To begin with, what is function? Function in programming language, in any programming language, is nothing but a collection of instructions designed to implement a specific task. Function is nothing but, which is an analogy to the analytical concept of function in high school algebra. For example, this is a function which is univariate function in particular. That is why univariate is the parameter under consideration in this function is only one, which is x. So this function is a mathematical function which is named by f, which is followed by parentheses, opening and closing parentheses. Within that there is a parameter x. Then it has also an expression tx plus 1. Now this function is a univariate function that takes values in, processing that value or operating that value. We expect to have an output value. For example, what's the output value of f if x is 2? The answer is nothing but we take value 2 for x, then we operate or evaluate with the expression provided x plus 1, where x is 2 now, then 2 times 2 plus 1 is 5. So this function in mathematics has three sections. Right? The function takes in value, operates the value with the expression provided, then produce an output value. This is the output, for example. The expression is this one. After taking specific argument, then this one is the function name that specifies the name and the argument. In other words, function can also be considered as factors, processing factors. We know that factors have three sections also, so that we obtain meaningful product. This is nothing but, as a first section, factors require inputs. Then second section, factors are needed to produce or process the inputted or arguments. But after processing, we are expected to have output around here. So functions can be considered as factory. Factory takes arguments, in particular raw materials in factory, but arguments in programming language, then process or evaluate. In that analogy, in programming language, we evaluate, we operate the inputted or the arguments, then after evaluation we come up with certain outputs. So similar to the programming language function concept and analogy to that function in mathematics algebra, there are three sections. The first section is having inputs, the second one processing those inputs, the third one is about getting an output value. Right? In this example, the center, the rectangular area is the center of processing, the factory where the inputs are processed. right? These inputs are get in through this, then process around here at the center. Then after processing, we expect to have output, which is retrieving section. So function in Python has similar concept to this function in factory, right? When we come back to the definition of function in Python, we define function using diff keyword, right? This diff keyword is useful to define function in Python. So, as we have said, function has three sections, like that of factory, like that of function in mathematics. The first section is header function, which starts with the keyword diff. The second section is the body section, which is collection of or block of codes. The third one is output section. So the header function is defined as follows. In Python, we define function using diff keyword followed by function name and parentheses ending with colon. This is the header function. For example, if you are interested to code this mathematical function in Python, we write first diff keyword, then followed by the function name, which is f in this context, followed by the opening and closing parentheses, within which there is one parameter x. Therefore, this line is nothing but the function definition header with one parameter x, whereas this section is body section of the function or block of code, where the task which is intended to be implemented is implemented around here. The third section is the retrieving output or result, which was implemented around here. So this section is section 1, header function section. This is body section. This one is output section. Therefore, when we execute this one by hitting enter and shift, this is nothing but executed with free of error. Now, when we run or execute a function, nothing can be displayed. Displaying the output of the function can be made using the print statement, right? Basically, executing the function can produce internal representation of the output of the function, but cannot be displayed so that users can read. But to represent that output explicitly, we force it to use the print function. For example, print f of 2. Print f of 2 is nothing but what will be the output of the function tx plus 1 if x is equals to 2. This statement prints the output of the function f for x is equals to 2, right? What will be the output of this one is nothing but 5, right? The other concept that we have to write here is the parameter and the argument. What is argument? Is the actual value when the function is called. What the actual value of x in this code is 2. Therefore, t is nothing but the argument, whereas x in this function definition is the parameter. Parameter is a variable listed within the function. So we have to distinguish these two things, argument and parameter, in writing functions. In Python, we may have one parameter, two parameter or more, or MPT parameter. For example, function with two parameters. Right? For example, div, let us add two numbers. Div add two numbers A and B, right? Where y, not y actually, result A plus B, the return result, right? Now, what's the function here? The function name is add. This is the function name. This is the keyword diff, which is useful to define function in Python. Now A and B are the two parameters. A and B are two parameters in this context, where this one is the implementation section, meaning we are processing or evaluating the task that we need to do here around on the body section. The third one is the driving output section. Now execute this codes by hitting Shift and Enter. Nice execution, no error. Now at this stage, A and B are n values that can serve as an input for this implementation section. Now let us call and print the result of some specific numbers. For example, print 2 and 3. No, add is a function. Now I am saying that print the result of the function add that takes arguments 2 and 3 as arguments, right? Print this prints the result of the function add that takes 2 and 3 as arguments. Therefore, this is nothing but the result of adding two numbers, specifically 2 and 3. Now 2 and 3 are nothing but arguments, but A and B are parameters. We need to distinguish these two important terms in function development. Right? This printing is useful to display the result of the function add to the user, explicit representation of the results. By default, this return section returns the result implicitly or internally, but to display, we force it to make use of the print statement like this. Let us use one more example having 3 parameters. For example, function with three parameters, right? The same function, but let us comment this one to make use of the same function name add in this context also, but we add one parameter, one extra parameter C. Now A and B and C are 3 parameters. This is implementation section. We add C. Then we drive the result, right? Then if I hit shift and enter, this is successfully executed. Now let us print add 2 3. What type of error that we could obtain if I ask Python to print add 2 and 3? This error is nothing but type error, which requires us to add extra position. One position is left, please add that one. This is nothing but this is an error, for example. This is type error, add function missing one required positional argument C, right? As the definition of the function, there was C parameter, but as the execution, as the invoking stage, we forget it. So this line produces error, this give error, which is type error, as there is missing one required argument, right? Therefore we add the third one, 5, for example. 2 plus 3 is 5, plus 5 is 10, right? This one is the right, but this one gives the error, right? This gives error. So the number of parameters in a function can be as much as we need. We can add more parameters in our function, such as A, B, C, D, E, F, separated by comma. But the important thing is following the coding instructions on the rules predefined in Python, such as indenting the implementation section from the header function by 4 space. As a standard in Python, we need to space 4 spaces indented this the implementation section and out section. Indentation is important in Python code writing. What the important thing is, function can also be considered as objects. These functions can be assigned to variables or can pass to the functions as arguments, right? For example, functions are objects, yes. Those functions can be assigned to variables, for example, r, which is r, for example, r 2 3 4. R is nothing but the retrieved value of this add function is now given to r. It can also be taken as an input in an argument. For example, can be assigned to variables, or can be assigned as an argument. For example, r1, this is for example r1, this one is r2 add, then 5 4 6. Now let us construct another function, multiply function. For example, if multiply function, multiply of 2 functions, right? Wow, in this case, what are these a and b are r1 and r2, right? where R1 and R2 are here. Therefore, y or result R is nothing but R1 times R2. Return R. Right? Now print multiply R1 and R2. Now this one are A and B. This one are A and B. This one and because they are parameters, we can name any regular variables A and B. Right? This one. Then now these values can pass as arguments to this one. Right? This is nothing but 135. Functions are objects that can be assigned to variables or can be taken as an input in functions and be passed as arguments to functions too, like this one. This is the function result, which is R1, function result R2. These R1 and R2 can be as an input or as parameters for the next function, right? Was the other thing related to functions are like how to invoke functions. Now the important thing is invoking functions. Invoking functions. Wow. Invoking functions are nothing but coding functions in the coding environment. Invoking functions follows the following three steps. To call a function, we use its name, right? Followed by the parenthesis, right? Example, add function, execute the code. This execute the code under it within the function, right? Within the function, when it is called, the function executes the code within it. Code execution. This is if the function is with empty argument, right? If there is a need to pass arguments with this parenthesis, we have to put there, right? Therefore, we can pass arguments as the case may be, or inputs. The function within the parenthesis. This is right. Example, add 2, 3, 4. In this example, when we execute this one, we are invoking the function like this one. This is nothing but invoking function add with 3 arguments, right? These are function execution, function call, function. To recall some concept about the built-in function, once the Python interpreter recognizes some built-in functions such as print, len, type, etc. These are examples built-in functions in Python. Whereas these functions, add, multiply, subtract, or other named functions, these all are called third-party functions, right? By the user. Any function can be developed by naming names except those keywords once recognized in Python interpreter. So the function that is written by the user is third party, whereas functions once recognized by the Python or collectively called built-in functions are called built-in functions, such as print, len, type, and etc. are built-in functions. In naming Python functions, we have to recall the various keyword functions in Python, such as if, while, this, is, in, not, else, and extra. The Python function naming can be any name, which is valid identifier, right? Naming for variables, naming for functions are equivalent. The name for function can start with letter or with underscore, but we cannot start using numbers or special characters while we naming functions in Python. For example, div to add a b. This function produces error, syntax error. Y a plus b return y. In this case, where is the error? The error is in the function naming, right? If I hit shift and enter, this gives an error, which is particular syntax error, invalid decimal literal. This is not appropriate naming of Python function. Python function naming cannot start with number or by any character such as this one. No, this is by itself error, but we can start by underscore. This is legal naming of Python functions. The same is true functions of Python variables too, right? See the next tutorial with Python collections such as tuples, lists, sets, and dictionaries, which are the extended Python data types in the form of data structure fashion. I thank you.